I'm Anil Kumar, sharing with you strategies which can help you prove trigonometric identities. So, for the beginners, this is a very useful concept. We'll prove trigonometric identities with the coordinate points xy and r is the distance from the origin. We have two examples here in which we'll apply our strategy. So when I'm saying x, y, r, I really mean that we'll consider coordinate plane, and within this coordinate plane we'll see a point, let's say P. So from the origin, the distance of point P is r, and point P could be written as xy with its coordinates, right? So if I drop a perpendicular from P to x-axis, in that case, we make a right triangle here. Let me call this point as Q. Now, the distance OQ will be x and PQ will be y. If this angle is theta, then we can actually write all these trigonometric ratios in terms of x, y, and r. So I hope now you understand what the question is. It says to prove identities with x, y, and r. So these values, correct? Now, let's also write down what is sine, cosine, and tan. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. So from this triangle, we can always write that sine theta will be equals to y over r. Cos theta will be x over r, and tan theta will be y over x. R is related with Pythagorean theorem. R square is x square plus y square, correct? So these relations which we have just written here will help us prove trigonometric identities. I'm taking very simple examples, but you can use this concept to prove even difficult trigonometric identities. Now, in every identity, we actually have two sides. We say, well, one side is our left-hand side, the other one is the right-hand side. So we call this as the left side, this is our right side, correct? To prove an identity means you should make left side equals to right side, correct? So to begin with, let's start with the left side. Tan theta, if you look into this triangle, is y over x. So we'll write tan theta as y over x. Cosine theta is x over r. Now x and x cancel, so the left side reduces to, let's cancel this first, y over r, right? You can say y over r is sine theta, correct? Sine theta, which is equals to right side. So at times it is a good practice to start from one side and to the other. So now since left side is equal to right side, we have proven the identity. So these are the basic steps, right? So let's do them once again for the next identity. Secant theta, so secant theta is what? Secant theta is reciprocal of cos, so we'll flip this. So it'll be r over x. Is that okay? So I'll replace secant theta with r over x, and cos theta is x over r. And of course, when you multiply, both get cancelled, so we get 1, which is same as right hand side. So we have again shown that left side is equals to right side, and therefore this identity is also proved, right? Let me take two more examples to elaborate on this. So now we have one trigonometric identity as tan square theta plus 1 equals to secant square theta. The other one is tan theta plus 1 over tan theta equals to 1 over sine theta cos theta. So let's make our right triangle here. So we normally make it as if it is in quadrant 1. The angle here will be treated as theta, and the x value, y value, and r, right? These are the values. And what we know here is that r square is x squared plus y squared, correct? So that is what we are going to use to prove these identities. So let's begin with the first one, which is tan square theta. So tan is y over x, so we can write this, so we can begin with left side. So we say y over x whole square. That is tan square theta plus 1. So that is y square over x square plus 1. We can take a common denominator of x square. So we get y square plus x square. Now y square plus x square is r square. So we have r square over x square, correct? Now that basically means r over x whole squared, correct? Now, so left side, as you have seen, is r over x. R over x is secant theta. So we could write this as equals to secant square theta. Do you see that? Which is the right side. So we have shown that tan square theta plus 1 is indeed secant square theta, correct? Okay, so this is slightly more complicated. Now let's begin with both the sides in this case. So we'll try to simplify both of them here. Is that okay? Right, so we'll write down what the left side is and what the right side is. Tan theta, as you know, is y over x. So for tan theta, I'll write y over x plus 1 over. Tan theta means y over x, correct? Now we can flip this. So we have y over x plus x over y, take common denominator, which is xy, and this is y squared plus x squared, which is r squared, correct? So r squared over xy, correct? Now actually speaking, I could go backwards and show it. Let me do that part. So we can say this is equal to, I could go like this also, but I'll prove from left to right. So we could write this as r over x times r over y. Does it make sense to you, right? So we are moving now in this direction. I could always write this as equal to 1 over x over r, correct? Bringing it down times 1 over y over r, correct? Now if I move further up, I could write this as x over r is cosine theta, so I have 1 over cos theta times 1 over sine theta, since y over r is sine theta, right? And that really means that it is 1 over, when you multiply, you could write this as sine theta cos theta. Does it make sense to you? Or if you move in this direction, you can say this could be written as 1 over sine theta cos theta. Now sine theta is y over r, cos theta is x over r, and then you can move in this direction and show it. That left side is right side or right side is left hand side. So with this example, I hope you appreciate that even this concept of taking a point on a coordinate plane can help you solve or prove trigonometric identities. Feel free to share your comments if you like and subscribe to my videos. That'll be even good. Thank you and all the best.